Hey everyone, for what values of x does our series converge absolutely conditionally? We're also going to find the interval of convergence. We're using the ratio test where the limit of n approaching infinity of a sub n plus 1 divided by a sub n equals our limit. And for it to converge absolutely, we're going to force it to be 1. Then we're going to test our endpoints to see if it's absolutely convergent on the interval of convergence. So basically, let's use the ratio test and take the limit as n approaches infinity, and we're doing a sub n plus 1. So everywhere there's an n, put n plus 1. n plus 1, absolute value of x plus 3 to the power of n plus 1, divided by 5 to the power of n plus 1. Now, we're dividing by a sub n, which is the same as multiplying by the reciprocal. I'll just copy down this there. All right, now let's simplify as much as we can. This should be absolute value here. Instead of putting it over the whole thing, I just put it over the x portion. Okay, now let's do the limit as n approaches infinity. Now this piece here is just going to be absolute value of x plus 3 to the power of n times absolute value of x plus 3 divided by absolute value of x plus 3 to the power of n. Now for the 5s, we're going to have 5 to the power of n divided by 5 to the power of n times 5. And then for my n's here, this is going to be n plus 1 divided by n. All right, so this part here cancels, these cancel, and what you're going to get is the limit. Let's pull this part out. So we're going to write this, this will be an eraser. Absolute value of x plus 3 divided by 5 times the limit as n approaches infinity of this right here. So we'd have n plus 1 divided by n right there. Now this is just going to equal 1. So what we get is absolute value of x plus 3 divided by 5 is going to have to be less than 1, which means absolute value of x plus 3 is less than 5 when you cross multiply. So let's look at that real quick. By definition, absolute value of x plus 3 equals is less than 5 is going to be x plus 3 is less than 5 but greater than negative 5. So if you subtract 3 from both sides, you're going to get negative 8 is less than x is less than 2. We want to test these endpoints for x. So when x is equal negative 8, you're going to get, let's just do the limit. We're going to do the nth test for divergence. So the limit as n approaches infinity, and we're going to substitute in 8. You get n times negative 8 to the power of n divided by 5 to the power of n. Now what happens is this is not going to be 0. The numerator is going to be larger than the denominator. So this is going to does not exist, or it's different from 0. So it doesn't, let's just put it diverges. All right, and then the same thing's going to happen for n equals 2, because you have this extra n here. So basically for 2, you're going to get the limit as n approaches infinity of 2 to the nth times n divided by 5 to the nth. And this is also going to be divergent. by the nth test for detergent, by the nth term test for divergence, because it's going to be different from 0. Therefore, our interval of convergence is just going to be -8 to 2. And our series converges absolutely on -8 to 2. Now, if these were convergent, it would converge absolutely on -8 to 2. I just want to show you the difference. But because the endpoints, they can't converge at the endpoints, we have to do open intervals here. So this won't work. Thank you. Have a nice day. Bye-bye.